There is no technique in biology that has taken off faster than CRISPR-Cas9. You may know it as genome editing. Why should a pulmonologist know about genome editing? Well, with me is Patrick Harrison. Patrick Harrison, you're leading a session today about CRISPR-Cas9 and genome editing. Why has it taken off so quickly, first of all?
It's so simple to use. It's a really important technique which can tell us so many things at so many levels. We can make very precise model systems in human cells to better understand lung disease. We can do this much more easily and more precisely with fewer animals and make better animal models. And it's already reached the clinic for 2 patients as part of an FDA-approved clinical trial. In terms of ease of use, we can make the Cas9 protein, which is the editing machinery. We've got a guide which will take us to a very precise region of the genome which we want to try and correct if we're looking at genetic defects. And a donor sequence will then seal the deal and correct the mutation. And we've got great animal data already saying that we can do this for many different genetic diseases.
Scarily, this is being done by undergraduates now. So this is not a complicated technique. It's super high quality precision, but it's easy. And perhaps that's the key to why it's taken off so quickly.
Yeah, you just need 3 additional reagents to the kind of experiments you'd be doing in the lab, and they're all very cheap. As I mentioned, we need the guide RNA, we need the protein, and we need the donor sequence. And if you put all 3 of those into the cell, then we can get this very precise editing.
Now, I'm going to give you the compulsory test, which is CRISPR. What does it stand for?
I can tell you the full version, but I'll tell you my version, which is how genome editing actually works. So we cut the DNA, we resect back to give us free ends, and they invade the donor sequence. This then leads to synthesis of the new sequence that we're trying to introduce. There's a small proofreading step, and finally repair.
I hope you were all listening to that, because there'll be a test later and I'll be asking you. Why should a pulmonologist be listening to this?
There's a lot of diseases out there which we don't fully understand, so having the CRISPR technique to allow us to edit cells, human organoids, which you'll hear a lot about in this session, this will give us a much better understanding of the disease. We'll also hear talks about how we can use these organoids to screen drugs, screen already FDA-approved drugs to see if they might work for certain patients. And certainly in the cystic fibrosis field, there's a lot of this, what we call repurposing, which has already transformed the lives and is extending the lifespan and improving the quality of life of patients already. This has been around for a couple of years now.
So there you have it, a very eloquent reason why you should listen to this session either at ERS Live Plus, or indeed go to it if you happen to be here. So it sounds very highly scientific, but actually I think that this is a key technology which people need to understand. Much more as we go on.